Thank you for giving us the opportunity to present at AGU, the largest annual gathering of climate scientists in the United States. The focus of this session is connecting people on a massive scale with climate science education. Reaching broad audiences. Whether you are a climate scientist or a climate educator, let's talk during virtual AGU. Can what we are doing benefit your work? We bring engaging, interactive, hands-on climate science labs to the public on a scale of hundreds of thousands in a single day. Who else does that? We may be middle school students, but we are also very motivated climate science educators. We play a big role in the largest science festivals in the country. The U.S. Science and Engineering Festival draws over 350,000 people in Washington, D.C. On the first day alone, 70,000 K-12 students and teachers arrive by bus and the metro for science field trips. In California, we provide several booths of climate science labs at the Bay Area Science Festival. So large that it is held in the San Francisco Giants baseball stadium. Who are we? Well, we're volunteers with the Mobile Climate Science Labs. The team speaking in this video is also a part of Climate Club DC. We are middle school students at Lowell School in Washington, D.C. We've created an entire playlist of videos on YouTube just for you. We hope that you check it out. It's for the climate scientists and fellow climate educators at the AGU conference. During the pandemic, we have adjusted to do more work virtually. Obviously, it will be a while before we are out again bringing climate change education to hundreds of thousands of people in person. In the meantime, we are making YouTube videos and we are holding Zoom calls with schools and student organizations across the U.S. and around the world. We would love for interested AGU climate scientists and education programs to partner with us in reaching broader audiences. Where else do we bring climate science when there isn't a pandemic? Large community events, some drawing over 300,000 people in one day. We stay where we are, in historically disadvantaged communities, and where people of color live, neighborhoods whose schools rarely have any quality hands-on science labs, let alone on climate change. Schools in California and DC come to be with us at field trip hubs. School groups bus in to do climate science labs with us. For instance, the Environmental Youth Forum and NASA's JPL's Climate Day. We are featured at youth summits and conferences. One is the Anacosta Environmental Youth Summit in Washington, D.C. We take part in large events in the national parks as well as state and local parks. We're proud to accept the invitations to take part in events hosted by organizations for young people, such as the Girl Scouts of America. The shortwave infrared cameras have really helped us understand how Earth monitoring satellites like NOAA, GOES, and NASA Terra work. It's common to believe that regular people can't understand the latest in climate science.
Now, basically, the only new principle involved is that instead of power being generated by the relative motion of conductors and fluxes, it is produced by the modal interaction of magneto-reluctance and capacitive directance. The original machine had a base plate of prefamulated amulite surmounted by a malleable logarithmic casing in such a way that the two spurving bearings were in a direct line with a panometric fan. The latter consisted simply of 6 hydrocoptic Marsal vanes so fitted to the ambifacient lunar wane shaft that side fumbling was effective.
We can help today's climate scientists communicate what they're learning about Earth's energy and climate to people who are interested. We are proving that ordinary people can understand it and that they can have a fun time learning. This is an area of study where discoveries can be made, and it's one way we can contribute to advancing climate science.
The infrared camera allows us to see invisible sunlight. Half of all the sun's energy that reaches Earth is invisible. And climate change takes place in the range of invisible light. So it's really important to study and understand it if you want to stop climate change. Shortwave infrared is a type of invisible light that looks similar to visible light. So it's easier to understand than other types of light. This is important because the more people understand how climate change works, the better equipped they are to take actions that really make a difference. My name is Bella.
My name is Nora.
And we live in Washington, D.C.
We go to Lowell School.
Today we are going to explain how climate change is affecting us now.
These are CO2 models.
We have learned to use these cameras for climate science education everywhere. At home, school, science festivals, museums, field trips, and even on vacation. The labs, demonstrations, and videos we can make using shortwave infrared are educational and fun.